So a little bit about basically future sediment accumulation. And this is based on models that the Corps of Engineers has run with what is the sediment doing now. And if we assume that the amount of sediment comes in stays the same and everything else remains the same, how will this delta continue to grow into Lewis and Clark Lake into the future? So again, here's a picture, air photo, Santee's here. You can see the leading edge of the delta and then Lewis and Clark Lake beyond it. So here is, using 2013 as a base year, this is the leading edge of the delta right here in 2013. If we fast forward by 50 years at the rate that it's filling in, the delta will have filled into the lake to just past Bonham Colony. And if we go 100 years from now, it will almost be to Wygon. And basically, Wygon would definitely be a very shallow place because there's sediment underneath the water there too. If we go 150 years from now, that's when the entire Lewis and Clark Lake fills in all the way up to Gavin's Point Dam. So the thing about it is that it doesn't take 150 years for the use and utility of the reservoir to be lost. I mean, even going back 100 years or even 50 years, if you start choking off this much of the reservoir, it suddenly becomes smaller and smaller and smaller. It affects water supply. It affects storage. It affects recreation. And that, of course, is one of the big things that everybody in this region is finding now, is just what is the economic impact of Lewis and Clark Lake for recreation. And obviously it's big. So if you start cutting the size of Lewis and Clark Lake down, you're going to impact that recreation benefit. And as you know now, on any nice weekend in the summer, Lewis and Clark Lake is like a bathtub full of toys. It brings in so many people, especially people from the Omaha and Sioux City area. A lot of people that aren't even from the region are coming up and utilizing that lake. So about the hydrology of the delta then. So we know that half of the sediment that's accumulating in the delta comes from the Niobrara River. And one of the interesting things that we really found in looking at this historical imagery and how the delta has moved over time is that the delta migrates downstream into Lewis and Clark Lake on average about 400 feet per year. So a little bit over the length of a football field each year. But that's just an average. And in reality, what we found is that it's the high flow years that's really pushing the delta forward. So in low flow years or normal flow years, the delta may not even move. At least visibly, we're not really seeing much movement. But whenever we have high flow years come through on Gavin's Point Dam, that's when the delta is really moving. And so in both 1997, that high flow year, and in the flood of 2011, the delta moved about 4,800 feet into Lewis and Clark Lake. So that's just short of a mile into the lake. And so that's pretty significant in terms of when you're moving the delta forward into what's left of Lewis and Clark Lake, a mile in 1 year, you've taken up a pretty good chunk of what's left of Lewis and Clark Lake. The reservoir has lost a little over 1/4 of its storage capacity. And another interesting effect that, of course, the town of Niobrara knows better than anybody, that's that as the delta sediments accumulate, they raise the riverbed where they're accumulating, and that raises the surrounding water table. And so groundwater levels are expected to increase an average of 7 feet in the delta in the next 50 years. So over the next 50 years, you could expect groundwater levels to come up another 7 feet. And of course, that will impact infrastructure and property.